Alright, now for tutorial question 7, okay, you are given that x and y satisfy the equation here as shown. Okay, so equation 1. Okay, and they tell you that if a real value of x is substituted, the equation becomes a quadratic equation in y. Alright, now they also tell you that two distinct real values of y can be found from this equation. Okay, so what we will do now is we will make use of the guiding step here, okay, where they tell us the equation becomes a quadratic expression in y. Okay, so let us re-express this as a quadratic expression in y. So we will get y squared. Okay, then we now search for all the y terms, okay, which are 16xy and 14y. Okay, so we now treat our x and x squares to be constant with respect to y. So we will get plus 16x in bracket plus 1, plus 14 multiplied by y, okay, plus our constant, which will be 4x squared plus 16x plus 13. Okay, so since there are two distinct real values of y, what we do now is we find the discriminant, okay, and we impose the condition that it has to be greater than 0 because we have two distinct solutions for y. Okay, so now what you should get is, okay, b squared, in other words 16x plus 14 squared, minus 4ac, so a is 1 and c is 4x squared plus 16x plus 13, must be positive. Okay, so expanding out, we will get 256x squared plus 448x plus 196. Okay, minus away 16x squared minus 64x minus 52 is greater than 0. Okay, so simplify this further. This is what you should get. Okay, and dividing both sides by 48. So if you divide both sides by 48, okay, you will get the inequality that you are required to show. Okay, so now let us look at the second part of the question, which asks us to hence. Okay, so take note of the word hence. In other words, we will be required to use this inequality here, 5x squared plus ax plus 3 is greater than 0. Okay, and hence find the set of possible values of x. Okay, so to solve this, we will just factorize the equation. Factorize the quadratic polynomial. Okay, so what you should get is, since the roots are negative 3 over 5 and 1, and negative 3 over 5 and negative 1, and the smaller root is negative 1, so our graph will look something like this. Okay, so we have x to be smaller than negative 1 or x is greater than negative 3 over 5.